UPS Basic Knowledge. UPS Working Mode. To start with, we will learn about the double conversion online UPS structure. From the diagram, we can see that the main components of UPS are the rectifier, inverter, static bypass unit, charger, and battery string. Usually, the power grid inputs to the rectifier and then to the inverter. Lastly, the inverter outputs stable AC to the loads. Now we will learn how UPS purifies AC input and is able to output stable AC. Let's look at this diagram. Firstly, the power grid outputs an unstable AC input to rectifier. Then, the rectifier converts this unstable AC to stable DC. DC is stable as it provides a constant current. Next, the stable DC inputs to the inverter. And inside the inverter, the stable DC is converted to stable AC. This double conversion is how the UPS purifies the AC input and then outputs stable AC. Next, we will learn the main components of UPS. First, we have the rectifier, and as mentioned previously, one of its functions is to convert AC to DC. Another function is power factor correction. Without this, the UPS input power factor is very low, which will cause a disturbance in the power grid. After all, we don't have control over the other devices on the grid when protecting our loads. Lastly, the voltage must be increased, because the inverter circuit is a voltage-reducing circuit. In order to make the input and output voltage of UPS roughly the same, the rectifier needs to increase the voltage. Focusing on the inverter, its function is to transform the DC to AC. The DC can be from two ways, from the rectifier or the battery. Now we'll look at the static bypass unit. Most of the time, in normal mode, UPS works alongside the rectifier and inverter, assuming that the mains input is normal, but the inverter is damaged. What will happen? Well, without the static bypass unit, the UPS would shut down. In order to avoid this, we need the static bypass unit, so that if the UPS fails, it can automatically switch to bypass mode, and the switch time is 0 milliseconds. If the UPS is working in bypass mode, alarms will be activated. When an engineer arrives on site and finds the UPS is damaged, they'll need to replace it with a new one. But during the replacement, the load still needs to run. So how is this achieved? On this occasion, we need the maintenance bypass, as during the replacement, we can switch on the maintenance bypass switch to release a continuous power supply for load. And then, as the UPS is isolated from the system, we can replace it. The last feature is the charger. Its function is obvious, charging the battery. Now, we will look more closely at the UPS working modes. The majority of the time, the UPS works in normal mode. In this mode, the mains supply power to customers' loads, using rectifiers and inverters. At the same time, the charger is charging the battery. If the UPS is in any other mode, it indicates an abnormality, and the alarm will be triggered. If this happens, the UPS needs to be manually inspected. Battery mode. In this mode, batteries supply power to customers' loads. The backup time is due to battery capacity and load capacity. There are two situations in which the UPS might switch to battery mode. One is AC input failure, and the other is if the AC input voltage or frequency exceeds the range, being either too low or too high. In summary, when AC input fails, or the voltage frequency exceeds a certain range, the UPS will switch to battery mode from normal mode. The switch time is 0, and the inverter must be running normally. Bypass mode. In this mode, the UPS supplies power to customers' loads through the static bypass unit. Why would we need to use UPS in bypass mode? As we saw previously, static bypass units are needed to prevent loads shutting down when the mains input is normal, but the UPS is faulty. Therefore, the answer is that bypass units are required in times of UPS failure, perhaps due to overloading, overheating, or another type of damage. As already covered, remember that the UPS can switch to bypass mode from normal mode with a switch time of 0. Another question. If the UPS works in bypass mode and then the mains fail, will the UPS work in battery mode or not? No, as the inverter has already failed. Remember that there is no battery backup capability in bypass mode. Therefore, if the mains fail, the load will no longer have power supplied to it. ECOO mode. ECOO mode is an energy-saving mode, which you can configure on the LCD or web user interface. In ECOO mode, when the bypass input voltage is within the ECOO voltage range, the bypass static switch turns on, and the bypass supplies power. The UPS transfers to normal mode within 4 milliseconds in case of bypass failure. When the bypass input voltage is out of the ECOO voltage range, the UPS transfers from bypass mode to normal mode. In bypass mode, or normal mode, the rectifier keeps working and charges the batteries using a charger. ECOO mode is highly efficient. So, is ECOO mode different from bypass mode? Yes, because in bypass mode, the inverter is faulty. But in ECOO mode, the inverter is just in standby mode. Usually, this function will be used in a place where the power grid is strong and stable, or else the UPS will frequently switch from bypass to normal mode, which is harmful to the UPS. At last, we come to maintenance bypass mode, which, as we said before, is only used when the UPS is faulty. During UPS replacement, the loads still need running, so we can manually switch on the maintenance bypass switch. This is how it happens. First, the UPS fails. Then, the UPS will activate an alarm, and the engineer receives this. And then, they will check the UPS. If the UPS is damaged, they will manually switch on the maintenance bypass switch, and then replace the UPS. During the replacement, the loads can still work, but without protection from the UPS. That's all for this section. Thanks for watching.